Okay, so today we're going to explain to you how to do lab number 3, electric field mapping. The objective of this lab is to be able to draw an electric field using equipotential lines. So first we're going to need a little bit of theory to understand the lab. So first, what is an electric field? Basically, any point charge creates its own electric field, as you can see here. And that just means that if you were to place a charged body, it would feel a force. So the electric field lines, which are these, always go away from positive and towards negative. So if I were to move this around, you can see how the lines still go away from the positive. And then if I added in a negative, you can see how the lines go towards the negative. So then next, what are equipotential lines? So basically, equipotential lines are just places where the voltage or potential is the same. So we can see it with this sensor. So you can see here, this is negative 0.14 volts. And then I can draw a line. So this entire line is called an equipotential line. And each point on this line is 0.14 volts. Okay, so now that we understand what an electric field is and what equipotential lines are, we'll show you how to do the procedure.
Okay, we're going to start by setting it up. So the materials we need are a power supply, conductive paper with a metal backing, a voltmeter, 2 regular wires, and 2 wires with circular magnet backing. To start the procedure, we're going to set the power supply to 10 volts. Then we're going to take one of our regular wires, put it from COM directly into the negative terminal. Then we're going to take the other regular wire, put it in volts coming directly out. Then we take one of the circular magnet wires going into the positive terminal. And you can choose any coordinates you want, but today we're going to choose 8 and 10. Then you put the other circular magnet going into the negative, coming out of the negative terminal, going to coordinates we choose are 21 and 10. And you set your voltmeter to DCV, preferably 20. Now we're ready to turn on the power supply and the voltmeter. So you take your wire coming from the voltmeter and you can start testing points and looking at the values appearing on your voltmeter. So to show that as you come towards the positive point charge, you're getting higher and higher numbers. If I start far away and approach it, the numbers are increasing. Same thing if I approach the negative point charge, the numbers are decreasing. So if I go to a random point, the number that appears on the voltmeter is the amount of volts created at that point.
So we're going to begin by finding our equipotential lines. The first one we're going to be trying to find is 5 volts. So we take our regular wire and then move it around like you said before. As you can see, the values are changing on the voltmeter. So now we're around 5. We look at the coordinate, which is 14 and 10, and mark it down on our graph. And we're going to be trying to find 5 to 6 points that are close by. So we'll keep looking around. And then again, we found 5. So that's 14 and 15. We're going to notice a pattern forming that all the 5 volt charges are in the middle of the graph. So we'll get another one, which is 14 and 4. What time was it? 14 and 1.
Okay, so as you can see, we have our 5 dots from before when we found the 5 volt lines. So these just mean that at each of these points, it corresponds to 5 volts. So now to draw your equipotential line, you're just going to sketch, you're going to kind of connect the dots, just sketch it. This should be a pretty straight line. And then just mark down how many volts it is. So now you can see this at this line, all of the values along this line are 5 volts. Now we'll try this again with another value. We chose to do it with 7 volts.
So we're going to be repeating the same procedure that we did with the 5 volt line with the 7 volt line. So we take our regular wire and move it around the paper. And as you can see, we're getting close. So now we found our first 7-point line, as you can see. So the coordinates for this one are around 4.9 and 4. So we mark that yet again on our graph. And we go back to looking for it again. So here's another point. we get 9 volts and 6.5 volts, and marking it again on the graph, 9 and 6.5.
Okay, so you want to find at least 5 or 6 points that correspond to the same voltage in order to draw your equipotential line. So we found 5 points that corresponded to 7 volts. So again, like with the 5 volts, you just want to sketch it by connecting the dots. And then just mark down that this is your 7 volt line. And then you repeat this for about 7 lines so you can get a good idea of what your electric field looks like. So as you can see, we've sketched out 7 equipotential lines. So now we're ready to start drawing our electric field lines. So there's 3 main rules to remember when you're drawing electric field lines. None of them can cross over. They have to either create a circle or go off the page and come back on. They can't randomly end on the page. And they are always perpendicular to your equipotential lines. So for example, and they always go from positive to negative. So for example, if you want to start here, you make them perpendicular, and then it's going to start to turn towards the negative, and then it's perpendicular here, and then it starts to turn towards the negative, and again, you can see that all of the lines are perpendicular to each of our equipotential lines, and it goes from positive to negative. So then you can draw another one coming from here, and it would look something like this. Like that. And then you can draw as many field lines as you want. You want to have a good representation of each side of the positive and each side of the negative. Okay, so this is what your final product should look like. So you can see a good amount of electric field lines, so you get an idea of what kind of force a point charge would feel if it was put here, for example. You can also see that each line is perpendicular to the equipotential lines, and none of them cross over, and none of them randomly end in the middle of the field. If you were to use a different kind of field, for example, we did a negative, positive, positive, you can see how the equipotential lines change and how the electric field lines change, but they still follow the same rules. They don't cross over, they go from positive to negative, and they're perpendicular to our equipotential.